I think I was 13 years old when I first got to know that the problem of chess is a really very high dimensional problem. I read a book on chess, and it said that the number of possible moves is about 10 to the power 120. And that was the time I got really fascinated how human mind really works on problems like these and still produces great grandmasters and people who can even beat computers. 10 years later, obviously, Kasparov was beaten by IBM Deep Blue. And today, we know that AI has done incredible work in the areas of games. Right? It's so many different games. AI has just outperformed human beings. And that gives us this real hope that AI will change the world. But then the experience and frustration of working for corporate America, unless you're working for Google, is that you don't see some of these changes actually result in growth, in profitability, and all kinds of outcomes that we actually look for, right? This is the biggest frustration I see is you see so much progress outside in the world of games, in the world of other things, but when you think of your own organizations, somehow driving impact with AI seems to be hard. And in the next few minutes, I'm going to try to unpack why this is so hard. And before that, let's just appreciate a little bit about what DeepMind has been able to do with building this AlphaZero, right? They have actually managed to create a system that instead of searching for those 10 to the power 120 moves, actually only searches for 10,000 moves, as opposed to other games like Stockfish and others who actually search for 10 millions of moves. They've done something really clever with AI. But why is that it's so hard? From an algorithmic standpoint, yes, AI is doing extremely well in games like chess and other places, and you can certainly transfer that. But why is that in real-world problems, this AI doesn't translate to impact? First let me just break this to you, that there is more hype than reality as far as AI is concerned. I have this one experience of Sophia. I'm sure all of you have heard of Sophia and may have seen it on Jimmy Fallon's show or other shows. Just before this event, I got an email from from this organization saying, we actually can bring Sophia to your events and actually can help the audience connect with the future of AI. Actually, I happened to be in one of those events 2 years ago, where one of the organizers backstage told me how carefully choreographed every single move of this Sophia is. It's practically no AI, right? It's entirely fabricated, fully fabricated, right? The sequence of questions are fully known, the answers are fully known. All it does is produces the natural language in good time, right? That's it. So there is certainly a lot more hype than reality. That's one thing we should already be fully aware of. But then we've also talked about how to actually solve real-world problems. We not only need AI, this is a topic I have spoken a lot about, is you need AI. Certainly you need algorithms that match or exceed human capabilities in a broad range of cognitive tasks. But then you have to also bring in significant capabilities of engineering, which is about measuring, collecting all kinds of data, connecting those pipelines in real time, and solving problems at scale. That requires significant engineering challenge. That's a significant engineering challenge, and it's always much, much harder in the real world than in the world of games, right? In the world of games, it's fairly clear, right? In the chess or Go, there is no data engineering challenge. It is an algorithmic challenge, fully an algorithmic challenge. And most importantly, the challenge of design. In two-person perfect, most of the places where AlphaGo has done phenomenally well, or DeepMind has done phenomenally well, are two-person perfect information games, right? No stochasticity, no uncertainty, right? And the rules of the game are fully clear. The objective function is clear. Most of the time, we are dealing with problems in the real world where we don't know what the objective function is, right? And where we don't know how to measure success. We don't know how to frame the problem. And if in the next 15 minutes, I'm going to give you a few examples of where framing and reframing problems has actually resulted in big success. And we have seen examples of AI failure. Certainly, we have seen Tay, which failed miserably within a day, right? Because AI wasn't good enough. We have seen examples of Amazon Go, where the complexity of the overall problem was so huge that while the promise is there, it's still not fully real in as wide a scale as we thought it would be possible. And part of this is because the problem itself is very hard to solve, right? It's really at the extreme, at the top right-hand corner of this axis of highly complex missions and highly complex sense making. And that's when some of these problems, like what Watson has been trying to do with automating medicine, or Amazon Go has been trying to do with automating retail, or driverless cars have been trying to do, have not yet succeeded because the complexity is just that high and the last mile is really, really hard, right? But let's focus for now on all things except for engineering and AI, right? We know AI will get better. We know data engineering will get better, and that is critical to solving big problems. But a vast area of success lies in actually understanding and solving the problems better. And if you look at a whole range of ways of solving problems, right? There are different varieties of problem solving. There is the management consulting variety of problem solving. There's a design thinking or human-centered design way of solving problems. There's a software development lifecycle and the agile modifications to that, which is another way of problem solving. There is the typical analytical problem solving, how we have solved problems in analytics over the years. And there is a behavior architecture kind of problem solving that one of our subsidiaries, Final Mile, does. And you can see that they all have somewhat different stages and somewhat different strengths in solving problems, right? But all of them have basically three fundamental stages, which is one is how do we define the problem very well? Second, how do we solve once we define the problem? And three, how do we implement the solution? Basically, these are the three stages with some differences. Now, we'll see that some of these techniques are better suited to some kinds of problems. If it is a strategy consulting problem where you have to recommend, all you have to do is to recommend the right decision, then the management consulting ones work really well because there is a lot of time spent on firstly defining the problem very well, and then also interviewing the stakeholders and building hypotheses, because these are one-off problems. Right? There's not a lot of data. When there is a lot of data, management consulting management consulting approaches starts to fail because it's really not data-driven. It is very hypothesis-driven. If you think of design thinking as a problem, when the problem is about service design or product design, where understanding the user, empathy with the user is super critical, it works really well because, again, like in management consulting, there's a lot of emphasis on problem definition and reframing the problem, right? Whereas if you look at software development, that's where it really fails. And any one of you who's either been in IT or has engaged with IT, which is practically all of us in this room, know that when it comes to IT projects, unless you define the problem so clearly, you just will fail, right? Because IT will want you to define exactly the functional specifications before going on, and there is that, the iterative loop is missing. And some of these agile methodologies have come in which have actually improved that to some extent. You look at analytical problem solving, very appropriate when there's a lot of data available, but then what it does not do is understand the user better, empathize with the user, or look at interview people, right? There's no input coming from actual human beings, and the general assumption is that everything good is already in the data, and that sometimes is a limiting assumption. The good thing that behavior sciences or behavior architecture projects do is to actually understand and create non-conscious design to solve the problem. So there are pluses and minuses of all of these, and in the next few minutes I'm going to talk about how to some examples of framing problems better and solving problems better. Let's start with one example. Okay. Now, a few years ago, one of our clients asked us this important problem, which is to predict which patients are not likely to take their drugs on time. Okay, this was the problem framed at us, and we ended up building a whole host of models. And what we discovered after building those models was that the best guess about which patients will take their drugs on time is to look at what they did the last 6 months. If you're a kind of person who does not take their drugs on time, you will continue not take your drugs on time. And none of our analytical models could do much better than that, right? We made some minor improvements, but what we realized is that the implementation cost is just too high. And we said, you know what, this problem, the best guess as to who is not going to take their drugs on time is just past behavior. Now, and therefore we closed off that project as a not a very big success, right? Now, when we look back and think about what this problem really was, this was not about predicting medication adherence. The real problem here was improving medication adherence. And if we had just stepped back and said, no, the whole idea is improving medication adherence, it's not just about predicting, and maybe prediction is not even required. When we frame this problem as a prediction problem of who is likely to take their drugs on time, we are making an assumption. The assumption we are making is that it is very expensive to do any intervention with all patients. Therefore, I must direct my attention on the few patients that are not likely to take their drugs on time so that they will start taking their drugs on time. And that's not necessarily a good assumption. Maybe there are very cost-effective ways of improving medication adherence. And if you looked at that, we may have hit upon solutions like these. Now, this is a solution called PillPack, bought by Amazon for $1 billion last year. And what it does is it uses a sophisticated set of robotics and AI, but what it does is simplifies the consumption of medication by giving them a daily dosage. You can just peel off that dose for the day, and all your drugs will be there in that one pack. And every day, you know exactly, at every day or every time of the day, it'll give you exactly what you need to take. Especially for people who take a lot of medicines, this is really simple, intuitive solution and improves medication adherence. Now, we couldn't have hit upon this solution if we had taken the limited view of the problem that we had taken at that time. So a great idea is to always never to actually take the problem statement as a given, but to really challenge and say, do we really understand this? Is this broad enough? Do we have a measurable way of success? When we challenge the problem statement and tinker with it and revisit it every so often during the entire engagement life cycle, we've seen that we are able to solve problems better. Now, let me give you just one more example of a recent success of reframing a problem. Our problem was how to improve e-commerce transactions for a chocolate manufacturer, right? And the idea here was that for most of the chocolate category, transactions are 20 to 30% of the revenues come from the checkout aisle, right? As you're checking out, you look at some chocolates, and you're already hungry, sort of depleted for the day. You pick up, put those in your basket, and that's 20 to 30% of transactions. And imagine when those transactions move to e-commerce, right? There is no checkout aisle there. There is no impulse transaction. And even if you buy, it's going to take you at least 2 days. Maybe Amazon will deliver in a few hours, but you want to eat your chocolate right now. And so where is the impulse transaction, impulse purchase in e-commerce? And our problem statement, when we started out, our problem statement was, how can you create this impulse-like behavior online? Like, how can you drive impulse e-commerce transactions? And we took that problem statement and we really worked with it. And after lots of research and lots of brainstorming, I think the one insight we came up with was that we can reframe this problem. And the big pivot happened when we reframed this problem as not increasing e-commerce transactions, but increasing e-consumption. We said, look, you already have chocolate in your refrigerator. All we have to do is to trigger you to consume the chocolate at this point of time. Don't have to buy the chocolate. You consume the chocolate, and we know when you consume chocolate, you're going to buy more, right? So by reframing the problem, we could move to a solution that was game-changing, and we think it's actually a game-changing solution in this category, right? So a good example of, again, not just taking the problem as a given, but revisiting it. Okay. I'll give you a third example, and this is a few years ago, but we were working with a call center provider who was selling credit cards on phone. And they were selling Discover credit cards, and the idea was this company was one of the 4 vendors who was making these phone calls. And so they sent out a data set to us and said, look, we have this data set. We want to find out which customers are likely to buy credit cards because we want to do better with Discover, right? And the first thing we did was it was a very small data set and very limited number of columns. We built a very quick model, and we realized that there was a column there called model rank. And we realized that, so the data set was like customers and whether they bought the product, whether they bought the card or not, right? And we had one column which said model rank. And we realized that one column is a very good predictor of whether customers are going to take the credit card or not. So we went back to them and said, look, you already have a variable. Looks like Discover is providing you this data set, and this data set has a column called model score, and model score does a pretty good job of knowing which customer is likely to take the credit card or not. Right? We can't really help you. And they said, look, yes, we know this column exists. We already do some kind of prioritization based on that, but we are struggling. So then we went and met them in a meeting, and in their offices. And then what we realized was that this was not really exactly their problem statement. Their problem was actually different. They were trying to increase. They were being measured by Discover on a metric called sales per hour. They said, look, our problem is we have to increase the number of sales we do per agent per hour, and we are doing not so well. The other 3 vendors are actually doing better. So yes, we're using this column to prioritize, but somehow we are not succeeding. So are there any ideas? And once we uncovered that the real metric of success is sales per hour and another metric called contacts per hour, we went back and said, but figuring out which customer is likely to convert is not the only way to get to that answer. We realized that they were making phone calls across the United States. So there were 5 different time zones. Right? So you actually could figure out which time zones, what time of the day is most effective to call customers, number 1. Number 2, we figured out was that all agents were not equally effective. Therefore, if you could assign the right agent to the right customer, we could be more successful. Third was that there was a concept of recycling of leads. When they would make a set of phone calls, and many phone calls will end up being in voicemail or busy or no answer and so on. And what we had to do is to have an intelligent logic for which customers to call again at what time. So for example, somebody's line comes busy. Should we call them back 30 minutes later, 2 hours later, next day? What do? It's in voicemail. How many times should I try? Should I stop trying after 5 times or 10 times? How many attempts should I make on a customer? There were a whole host of parameters that were there, which none of them were optimized. And when we put them all together into a solution which said, this is how we call, right? And once we get the results, we'll rescore the algorithm and figure out the strategy for next day. Every day we would get a bunch of leads. We'll know which ones to call, and we'll get some kind of resolution on each of these calls, and then we'll recycle those leads. And this system dramatically improved their overall success and sales per hour for them. Again, just going back and re-looking at the problem and looking at all the options and taking a wide enough view of what the problem statement was. So these are some examples of reframing the problem, and I would submit to you that if there's one thing that we should take out from this session is that never take a problem statement for granted, and reframing actually always helps. Okay, now let's come to the idea of designing the right solution. This is an example of working with one of the largest tea manufacturers in the world, and we were asked to build a forecasting model to predict the shipments and sales of tea in different parts of UK. Now, tea is a very saturated category, very competitive, very promotion specific, and the forecast accuracy was not very good. And our goal was to improve it by 5 percentage points. We ended up increasing by 8 percentage points. That was all good. And then we were asked to do this across a whole range of categories, and we were told that your objective is to beat the demand planner. There is a demand planner who's doing forecasting, and you have to come up with a forecast which is better than the demand planner, because we then will decide who to use. And we pushed back and said, no, why is this problem about beating the demand planner? Why isn't the problem of improving the overall forecast accuracy in coordination with the demand planner? Because one thing we realized was that demand planners have information that we don't have. For example, demand planners can make phone calls and can talk to retailers and saying, what are you going out of stock? What's going on in your... They have sensory or sense-making information coming from a number of different sources that we as data-driven people don't have. So if there is a forecast that a demand planner is making, and there is a data-driven forecast, is there an intelligent way to combine them to give you much better accuracy? Right? Once we looked at that kind of solving the problem, where we knew what the machine would do, what the human would do, and we looked at a human-machine collaboration, we could actually make some progress. Right? But this is not easy, because there is usually a lot of pushback saying, no, this is the way we have defined the problem is the only way to look at the problem. But this was one example where it helped. Now, also, I think most of the time, I would also say that when we are solving problems, we we also take this very strong view that changing behavior of users is completely based on a set of rational things, right? We have a very rational view of everybody, whether it is enterprise users, consumers, and so on. Most of the time, we are thinking of them as very rational people, and when we want to change behavior, we want to create the kinds of things like, let's create better rules and regulations. Let's give rewards and incentives. Let's do awareness and education. Most of our strategies are about appealing to the rational human mind. But when we actually build solutions for the emotional mind, for the elephant, right? The model of human being is that of a rider sitting on an elephant, right? Rider is very rational, but is not very powerful. But elephant is not rational, extremely powerful. When elephant wants its way, it'll do it. It'll do what you want. For example, at 10 in the night, you might tell yourself, I have to wake up at 4 a.m., do meditation, then go for a walk, then eat healthy for a whole day, etc., right? But when the alarm rings at 4 a.m., the elephant says, no way, I'm not getting up, right? That's what happened to us every day, right? We all have great intentions, and we are not able to act on those intentions because the elephant really runs the show, right? And therefore, some of the times, the way to shape the right behavior is to talk to the elephant, not to the rider. And what does the elephant do? So rider looks at advertising, education, rules and regulations, rewards and incentives. That's all rider stuff. The elephant stuff is about training. Right? It's about training. It's about shaping the path and shaping the environment where the user automatically does what is right. What is the behavior that we're expecting of them? And an example of that is playing music in an ice cream aisle, which increases the sales of ice cream by 40%, because that ice cream, that music triggers that in your brain, which helps you go and buy ice cream. Right? Examples like these, which are about what I'm trying to tell you is here is that do not just take a rational view of human beings. When you're solving a problem, also assume that there are human beings involved and they are not necessarily rational. And that translates to even things like information, right? We all are really submerged with the tons and tons of information every day, and we are struggling with information overload. And one of the ways in which we should get the right, if we expect people to read everything that you're sending to them, we're already making a big assumption. And what we have to do is to tell them what they need to know, information on need-to-know basis, so that they can cut down the information overload. So this is one way of actually even managing that aspect, right? Now let me also talk a little bit about the human-machine collaboration in the case of this Tesla car accident that happened a few months ago, right? Tesla, as you know, has a very good autopilot system. It works really, really well. I'm sure many of you drive that. It works really, really well. But that creates one problem, which is that the people who are driving it are not necessarily paying attention on driving, even though they're supposed to, right? And therefore, when the autopilot gives up and asks the human to take over, there's usually about 15 seconds delay, 15 to 40 seconds delay before the human being actually takes over. And that creates a huge accident risk. And this is happening because today the machines or the AI has been designed without this in mind, that there is a human-machine collaboration, there is a takeover that will happen. And unless it is really, really good, right? If the AI is perfect, you don't need the human being to do anything. But if AI is not perfect, we have to factor in the fact that human beings are going to take time to actually adjust. So when you're designing solutions like these, it's very critical to actually figure out the human-machine collaboration. Okay. Now, in the last few minutes, I'll just want to talk to you about design, on how to design solutions. And let me give you an example of this Amazon recruiting situation. As you know, Amazon built an algorithm that was supposed to algorithmically screen applicants. And they built it over 10 years of resume database, and then realized that it was doing a really bad job of discrimination against women, right? Resumes with women in leadership positions and various kinds of phrases which meant that there were women were actually getting screened out at a much higher percentage than otherwise. And then they went out and said, and then they actually scrapped the system altogether. Now let's see we're just imagining how they must have done this analysis, right? They would have probably taken something like this. They would have taken 10 years of resumes, and they would have made the following choice. Was the candidate hired? Yes. And if so, how did they perform? And if they were not hired, they rejected. We don't know how they performed, right? Now, the first question is, how do you measure performance, right? As you know, organizational performance determination is very, very subjective. It's a function of your opportunity. It's a function of your luck, function of your manager. There's so many different things. Measurement of performance is not really objective. So when you're building a model, and when the objective function itself is kind of very, very subjective, it's hard to know that it'll work. Second thing is the following, right? We have two ways of actually building this model. One is to say, let's maximize performance. So let's see, for all the people who were selected, let's maximize performance. Or I could say, let me replicate the human way of screening resumes, right? So let me build a model that predicts whether the candidate will be hired or not. I can maximize productivity if I take that first approach, which is will the candidate be hired? And I will maximize performance if I take the second approach. Which is the right approach? Not very clear, not very easy to determine. And thirdly, we don't even know, by the way, before that, we don't even know how, if you were to ask the question, how will the rejected people perform? We don't have answers to that as well. That's another question. Third question is the idea of gaming, right? Once you start algorithmically screening resumes, there's a full industry that is there, which is actually gaming the resumes in the first place. Now today, for a fee, you can actually make your resume in such a way that algorithms will actually look at you favorably. It can be done, right? It's a service available not just from search headhunters and search, but also algorithmically people will make the right recommendations so that you can get hired. So there's a whole problem of gaming, which also means that people who game the system will get hired. So there are several kinds of issues of fairness, of bias in building those algorithms, and if we are able to solve those problems well, we can certainly use these algorithms, but without that, it's very dangerous. Like in the case of Tesla, or in the case of algorithms like these, one sort of argument or one criticism one could come up with is, you know what? Humans are far more biased than machines. So why this higher standard for machines than for human beings? And the answer to that question is, human biases don't scale, right? If I'm a bad driver, really bad driver, the worst case, I'll kill myself and a few others with me. But I don't kill the whole population. But I have a really bad algorithm for driving, it can kill the whole population. So machines scale, errors scale. Therefore, it's actually wise to have higher standards for machines. And therefore, algorithms like these, even though they might actually be better than humans, we have to be worried about scaling errors. And therefore, we have to be very, very careful when we use these kinds of algorithms. Okay, and certainly, we also have this. I'll just skip all of this. A few months ago, when Model 3 was running into problems, one of the things that Elon Musk said is that excessive automation was a big mistake, and humans are very underrated. And I think there's an important point here to learn from here is that there are certain skills that humans have which machines still don't have. Going back to the question around computational complexity, like a game like chess has 10 to the power 120 possibilities. A game like Go has 10 to the power 360 possibilities. Human beings are very good at reducing the dimensionality of those problems and solving them. Machines, not so good so far. So therefore, there is value for human input. There's a value for domain expertise, domain experience, heuristics. And if we are able to match the two, that's when really good results can come in. Because in this case of Tesla, what they realized was that humans are actually very flexible. When production plans change and little things change, redoing the automation is very, very hard. Okay. Now, I'll just end by talking about the key challenges that you are trying to solve in your organizations. Right? If you're, as one of the Fortune 500 companies in the room, right? These are the 5 major areas in which you're trying to solve problems. You're trying to make better decisions. You're trying to engage better with consumers and personalize and win their loyalty. You're trying to reduce all kinds of inefficiencies, including risk, including claims, all these kinds of inefficiencies in the system. You want to build better products, and you're also trying to tackle disruption. If you want to do all of that, the one thing you have to do is to solve problems at scale, and that will come by actually bringing AI, engineering, and design. We spoke a little bit about AI and engineering, but most of the time we spoke about how do you frame the right problem. And my submission to you is that that's one place where there's a lot of low-hanging fruit. If we frame the right problem and solve them well, we will be able to solve problems at scale. Thank you.